Ready? I'm going to be showing two examples of where you gain a root. First example is radical x equals 2x minus 6. You see in this problem that you only have one x, therefore there's only one root. But in order to solve for it, you have to square both sides, giving you an extra root. Okay? That problem then becomes x equals 2x minus 6 squared. Then, in order to solve this, you have to FOIL, which becomes 4x squared minus 24x plus 36. And then you subtract x from both sides, and it becomes 4x squared minus 25x plus 36 equals 0. Then you use the quadratic formula to solve for the x. The quadratic formula is negative b plus or minus radical b squared minus 4ac over 2a. Then we're going to plug in the information. So the b, this is b, this is a, and this is c. So negative b is 25 plus or minus radical b squared, so negative 25 squared is 625, minus 4ac, which is minus 4 times 36, which gives us 25 plus or minus radical 49 over 2a. 2a is 8. Okay? Then you simplify that, and it becomes 25 plus or minus 7 over 8. Then we separate the plus and the minus to give us both of our options as answers, which comes back to explaining why we've gained a root, because in the beginning of the problem, we squared both sides, giving us an extra root. But the problem is, we were only given one x to solve for, so there can only be one root. So, to solve for that, first you have to solve for both possible answers. One of the answers is going to be 25 plus 7 over 8, and one of them is going to be 25 minus 7 over 8. Okay? This simplifies out to 32 over 8, which equals 4. Okay? And this one is going to simplify out to 18 over 8, which equals 2.25. Okay? Now, we have two possible answers. But since in the beginning, our equation had a radical x, you have to check your answer. So, checking for, plugging it back into our main equation, which was radical x equals 2x minus 6, you plug 4 in. So radical 4 is 2 equals 8 minus 6. Does 2 equal 4? It does not. So now we know, wait. I messed up. Okay, radical 4 equals 2 times 4 minus 6, which becomes 2 equals 8 minus 6, which makes 2 equal to 2, which is correct. Sorry I messed up. Half a second. It's okay. Don't blame me. Okay, cool. Then we plug in 2.25. Radical 2.25 equals 2 times 2.25 minus 6. That becomes 1.5 equals 4.5 minus 6, and 1.5 does not equal negative 1.5. So we see, based on our answers, that only one of these roots works, right? Only 4 works, and therefore, we have eliminated the extra root that we gained and have come back to our original 1 root. That is the first example of gaining a root. Now, if you follow me over here, I'll give you another example. example I have for you is radical 5x minus 4 equals x minus 2. In order to solve for the x, you have to square both sides, giving you an extra root. This becomes 5x minus 4 equals x minus 2 squared. Now, foiling out x minus 2 becomes x squared minus 4x plus 4 equals 5x minus 4. Simplifying, you subtract the minus 5x and plus 4. Minus 5x plus 4, it gives you x squared minus 9x plus 8 equals 0. To solve for this, you do key number and you get x minus 1 and x minus 8 equals 0. And you get x either equals 1 or x equals 8. Those are the two options that you got because you gained a root when trying to solve for the x. Now, you have to check and plug these two back into the main equation. So, when we try 1, try it over here. 5 times 1 minus 4 equals 1 minus 2. Does that work? Well, 5 times 1 is 5. 5 minus 4 gives us radical 1. And 1 minus 2 is negative 1. Does radical 1 equal negative 1? It does not. So now we know that 1 as the option of one of the roots does not work. Now let's check 8. Bring it back. We do 5 times 8 minus 4 equals 8 minus 2. Well, 5 times 8 is 40, and 40 minus 4 is 36. Radical 36 equals 6. We know radical 36 is 6, and 6 equals 6, which is correct. And we know that our 8, it does work. X equals 8 works, and therefore you gained a root to solve for the problem, and then you solved for the problem by checking your answers and went back to only using one root.